Angelo, and today we're going to look at some real world examples of linear equations and analyze them. So, a copy of the notes have been linked in Canvas, or you can get a copy when you return. So, we've actually already done a little bit of work with this in terms of looking at real world examples, analyzing what the parts mean. But now that we actually know the words y-intercept, slope, and we're comfortable with that, we're going to go ahead and look at a few more examples today. So, we're going to start with this graph. Just before we even look at the questions, this is describing John's savings account balance for the year. So we have the months, and then we have the number of dollars in savings. So the first question is, what does the y-intercept represent in this situation? So remember, the y-intercept is where your graph hits the y-axis, which is at this point right here. And that's at 300. So that point would be 0, 300. So what that's saying is before you even start saving, John started saving, I should say, he deposited $300 in his account. So that's what he's going to start with and then continue to add to. So John starts with $300 in his account. Okay, so typically that intercept is going to be your initial, the beginning, the start of whatever the scenario is. Okay, what is the slope and what does it represent in this situation? So slope is always rise over run. So I can pick any point. This graph, because the line's a little thicker, is a little harder to read. I'm going to go with this point right here. So notice this is going up by 100. That's the increment on the y. It's going up by 2 and then over by 2. So that's $200 that it's increasing by over 2 months. So he is saving $100 per month. Okay. So John saves $100 per month. So that's the rate that it's changing at. Okay. Just going to get a new pen. This one's dying. Okay. All right. So what does the 0.4700 mean? So in a point, we have X and Y. And looking at our graph, X represents months and Y is how much we have saved money-wise. So this is saying in 4 months, John, let me adjust this, saved $700. And then write an equation for the graph. So we're writing this in slope-intercept form, and we actually have all the information we need. Our slope is 100, our y-intercept is 300. So y equals 100x plus 300, okay? So in this problem, we analyze the y-intercept, the slope, a specific point, and we wrote an equation. You can definitely expect to see this on your test. There will definitely be a graph. I'm going to skip this next graph, and I want to flip to the back and talk about this equation and then the table. So Janice goes apple picking, and the equation below shows the cost per pound. That's really important, okay? This is your unit rate or slope, okay? Now this is in slope-intercept form. So y equals mx plus b. So y equals 3x. Now because there's nothing after the x, we assume it's 0. They didn't put anything there because they didn't need to. All right, so what does the y-intercept represent in this situation? Well, it's the situation is about Janice going apple picking and how much she's spending per pound. So your y-intercept is where you're starting, which in this case is 0. So basically, if she doesn't pick any apples, she's not going to spend any money. So Janice hasn't picked any apples, therefore she hasn't spent any money. Okay. And what is the slope? So we know in slope-intercept form, it's the number we multiply by x. and they tell us that represents the cost per pound. So that means, so the slope is 3. Um, this means each pound of apples costs $3. We know it's always y over x, so cost per pound. So $3 per pound. That's what it means. And then last, if you spend $24, how many pounds of apples can you get? So they're saying that I'm going to spend $24, and I know it's $3 per pound, so how many pounds did I get? So we're going to solve the equation. We find that x equals 8 pounds. Okay. All right, so this is analyzing an equation. So just remember y equals mx plus b when you're trying to dissect that and interpret what it means. And always make sure you read the situation once, twice, even 3 times through to make sure you've got all the information you need to decipher this. Okay. Last but not least, we're going to take a look at a table. This is the other way you can represent a linear equation. So Christy is draining her pool. And I'm going to box that word draining because that's an important word. Use the table below to see how long it will take her to drain her pool. So we have x at the top, y at the bottom. So that's really important knowing that this is a horizontal table. So what is the y-intercept in this, represent in this situation? So we know that the y-intercept is a point where x is 0 and we have a value for y. And that's because on the y-axis, you're not moving left or right, you're just going up or down. So in my table, I look to find where is x 0, and it's the first point. So that is 0, 10,000, okay? And what that means is, since we're talking about draining her pool, that is the number of gallons of water she starts with. So Christy starts with 10,000 gallons of water in her pool. So that's where she begins before she starts to drain it. Now, draining is important. That means it's going down. So it's going to be a negative slope. So I can see from here to here, she's losing 800 gallons while the time increases. So over time, she's losing water. So that's negative 800 change in y over our change in x, which is negative 400 over 1. So she's losing 400 gallons of water each hour. So Christy loses 400 gallons of water each hour. Okay. So that's how much the rate she's draining it at. What does the 0.2 9200 mean in this representation? So 2 is x, 9200 is y. So x is time in hours. So after 2 hours, this is how much she has in her pool. So after 2 hours, Christy has 9,200 gallons of water in the pool. Okay. All right. Last but not least, write an equation for this table where we've already done the work for it. We have our y-intercept 10,000. We have our slope of negative 400. So y equals our slope times x plus our initial amount. So she started with 10,000 gallons and she's losing 400 gallons an hour. So that would be our equation. Okay. So once again, you're going to see some real world examples on your test. You have to be able to dissect what those different part means. So your y-intercept is always going to be your initial, where you begin before you start, and then your slope is showing how the situation is changing over time. And we looked at how we can find this from a table, an equation, and a graph. So there is a worksheet for you to do in Canvas. If you have any questions, you can let me know, and I will see you soon.